15 মিনিট শিক্ষাৰ আজিৰ অনুষ্ঠানলৈ 15 মিনিট শিক্ষাৰ সমূহ সদস্যৰ হৈ মই হিৰণ্যনাথে আটাইকে আদৰণি জনাইছো। আজিৰ অনুষ্ঠানত আমি এটি অতি গুৰুত্বপূৰ্ণ আৰু সাম্প্ৰতিক কালৰ বাবে অতি প্ৰাসংগিক বিষয় আলোচনা কৰিম। এই আলোচনা কৰিবলৈ আমাৰ মঞ্চলৈ আমি আমন্ত্ৰণ কৰি আনিছো ডক্টৰ হিৰক জ্যোতি কাশ্যপক। হিৰক জ্যোতি কাশ্যপক আসলতে চিনাকি কৰি দিয়াৰ প্ৰয়োজন নাই, কিয়নো এই মঞ্চত তেওঁ এজন পৰিচিত ব্যক্তি। তেওঁ আগতেও এই আমাৰ 15 মিনিট শিক্ষাৰ মঞ্চত অসমৰ কলেজীয়া শিক্ষাৰ্থীসকলৰ কাৰণে তেওঁ অনুষ্ঠানত অংশগ্ৰহণ কৰিছে। তেওঁৰ জন্ম নগাঁৱৰ ভেৰভেৰি গাঁৱত আৰু তাত তেওঁ প্ৰাথমিক আৰু হাইস্কুলীয়া পৰ্যায়ৰ শিক্ষা গ্ৰহণ কৰি তেওঁ নগাঁও মহাবিদ্যালয়ত উচ্চতৰ মাধ্যমিক, তাৰ পিছত স্নাতক পৰ্যায়ৰ শিক্ষা গ্ৰহণ কৰে তেজপুৰ বিশ্ববিদ্যালয়ত। তাৰ পৰা তেওঁ আহে NIT ৰাউৰকেল্লাত স্নাতকোত্তৰ পৰ্যায়ৰ শিক্ষা গ্ৰহণৰ কাৰণে, আৰু তাৰ পাছতেই তেওঁ আমেৰিকা যুক্তৰাষ্ট্ৰৰ আৰভাইন চহৰত থকা ইউনিভাৰ্চিটি অফ কেলিফৰ্ণিয়াত তেওঁৰ গৱেষণাৰ কাৰণে আহি আজি 2 বছৰ আগতে তেওঁ ডক্টৰেট ডিগ্ৰী লাভ কৰে। তেতিয়াৰে পৰা তেওঁ স্যামছাং ৰিচাৰ্চত সিনিয়ৰ সফটৱেৰ ইঞ্জিনিয়াৰ হিচাপে কৰ্মৰত হৈ আছে। আজি হিৰকে আমাৰ আগত আৰ্টিফিচিয়েল ইন্টেলিজেন্স মানে কৃত্ৰিম বুদ্ধিমত্তাৰ বিৱৰ্তন আৰু সাম্প্ৰতিক যিবিলাক ধাৰা সেই সম্পৰ্কে আমাৰ ছাত্ৰ ছাত্ৰীসকলৰ কামত অহাকৈ কিছু কথা ক'ব। আৰু আসলতে আমি কৃত্ৰিম বুদ্ধিমত্তাৰ ওপৰত এলানি বক্তৃতাৰ আয়োজন কৰিম পৰৱৰ্তী পৰ্যায়ত, আৰু সেই বক্তৃতাসমূহত হিৰকেই নেতৃত্ব দিব। আমাৰ এই অনুষ্ঠানটোৰ প্ৰথম 30-35 মিনিট হিৰকে বিষয়টোৰ ওপৰত কিছু কথা ক'ব। তাৰ পাছত এই প্লেটফৰ্মত উপস্থিত থকা বা জুম বা ফেচবুক আৰু ইউটিউবত উপস্থিত থকা আমাৰ অংশগ্ৰহণকাৰীসকলে তেওঁৰ উদ্দেশ্যে প্ৰশ্ন সুধিব পাৰিব। সেই প্ৰশ্নসমূহ এই অনুষ্ঠানটোত উপস্থিত থকা 15 মিনিট শিক্ষাৰ আন সদস্যসকলে হিৰকৰ কাৰণে আগবঢ়াই দিব আৰু হিৰকে সেই প্ৰশ্নবোৰৰ উত্তৰ দিব। আমি আশা কৰিছো যে এই অনুষ্ঠানটোৰ পৰা আমাৰ ছাত্ৰ ছাত্ৰীসকল উপকৃত হ'ব। ছাত্ৰ ছাত্ৰীৰ উপৰিও এই অনুষ্ঠানত আমি জানো যে বহু অভিভাৱক শিক্ষক উপস্থিত আছে, তেখেতসকললৈকো আদৰণি জনাইছো। তেখেতসকলেও প্ৰশ্ন সুধিব পাৰিব। মই হিৰকক আমাৰ মঞ্চলৈ আদৰণি জনাইছো। হিৰক, তুমি তোমাৰ বক্তৃতা আৰম্ভ কৰিব পাৰা।
Thank you, sir. My slide to share কৰিব পাৰিম। দেখা পাইছে না?
পাইছো। তুমি ফুল স্ক্ৰিন কৰি দিব পাৰা।
দেখিছে না ঠিকে এতিয়া ফুল স্ক্ৰিন?
দেখিছো, ঠিক আছে।
ওকে। নমস্কাৰ সকলোকে। মই আৰু ছাৰক ধন্যবাদ ইমান ধুনীয়া এটা ইন্ট্ৰডাকশ্যন দিয়াৰ কাৰণে। বিশেষ সময় ইয়াতে নকটাই আৰু 15 মিনিট শিক্ষালৈকো ধন্যবাদ মোক এই সুবিধাটো দিয়াৰ কাৰণে। বিফৰ মই ইংৰাজীতে ক'ম বেছিভাগ, তো আপোনালোকৰ কিবা যদি প্ৰশ্ন থাকে, কুৱেশ্যন থাকে, মোক মাজতে ৰখাই দিব পাৰে, চেটত লিখি বা শেষত আপোনালোকে বুজি নাপালে সুধিব পাৰে যদি ইংৰাজীৰ কাৰণে কিবা বুজা নাই। তো মই টকটো আৰম্ভ কৰিম ইংৰাজীতে। তো artificial intelligence is now a big field in not only computer science but in whole technology domain. As you have heard or seen recent like in the news that some artificial intelligence or AI model solving or like beating like the best chess players or best Go, like another chess kind of program. So this is coming in a big way. So it is important to reflect back how this field or this research has evolved over more than last 50 years. and what are the current challenges, and how, for example, in the context of Assam, where it can be beneficial to us, and where we still need to like work on, or we are lagging behind the rest of the world. So I would start with a small movie clip. Please bear with me. This will be the last clip of the movie, of like any movie in this one. So here, to give in context, this scientist is making a robot by transferring all the knowledge in a human brain to a robot brain. So this is the first depiction of creating an intelligent being in a movie, which is in 1927, very old. So that is laudable. So here's the robot. And there is a person lying here, and the brain is transferred. And then suddenly the robot got humanified. And this is the person whose brain was transferred into the robot's brain. So this is just to show that what people visualized artificial intelligence or robot intelligence as like almost 100 years ago. This is a German film called Metropolis. And since then, this visualization or so this is what people expected. There would be a robot who will replace humans. But this expectation has changed over the last century, let's say. And now it may be like this, but now the expectation is more realistic, how AI impacts our daily lives rather than like creating a clone of a human. So during this 100 years, like a lot of, expectation upswing, downswing happened. And where we are now is a realization of different efforts and like different upswings and downswings in AI investment and research. So to say the first, a conceptualization of artificial intelligence. So after this movie, the World War II happened, then most of the research basically stalled. And this person, Alan Turing, he is regarded as the father of computer science, or like a pioneer, let's say. And even he was, so he's the inventor of the Turing machine, which tests whether a problem is solvable or not. So during the World War, even he was involved in decoding the German cryptic messages encrypted by the Enigma. So yeah, so during the World War II, all this robot or the AI hype went down. And after that, in 1950, Alan Turing wrote an article called Computing Machinery and Intelligence. So I'm sure you have heard of this film called The Imitation Game. I think it came up a couple of years back. So it was his biography, the movie. So in this paper, he actually brought up the imitation game. And the game is that if there are like three people, one people sitting in room one, two other persons sitting in room two, one male and one female. The job is for the person sitting alone to to determine which person is male and which person is female without hearing their voice, just by asking question. So in this imitation game, he asked, if we replace one of the male or female players with a computer or with a robot, will the other person be able to still figure out which one is, or will the robot be able to deceive the other person as either male or female? So just by answering questions in particular way. So so his idea of intelligence was that it needs to be something that can at least impersonate a human, that then we can consider it as intelligent. That might be like a ultimate goal, but definitely he acknowledged that we need to start something primitive. So imitation game maybe was just one narrow example for human intelligence. So the first AI program to say was developed in 1956. It was called Logic Theorist. And this was by these two persons, Simon and Newell. So they made a computer program that can solve mathematical problems, theorems. So there is this book called Principia Mathematica. So it could solve most of these theorems in that book and gave better proof of detailed proof than the ones that were provided by the authors. So in that sense, this program, although it is intelligent, it is trained or it is designed for only one task, which is to solve the theorems. That's it. But still, it was the first demonstration that a program can actually do something better or equal to what humans can do intelligently. And more than that, this for like seminal program developed to like very important ideas in AI, which are like search tree and reasoning and the heuristics. And these two ideas are still in use. So this shows the impact that logic theorists had or still have on the AI community because of this kind of like ideas that are still useful. And another very interesting example of an AI chatbot, it was called Eliza. Actually, the inventor of the chatbot did not consider Eliza to be smart or intelligent, but other people who used Eliza thought Eliza to be a person. So they used it mainly for psychological patients, I think. So it used as a psychotherapist. So psychotherapist. So those patients thought that they're actually talking to someone, and they're like people, suppose with depression and problems like that. They thought their conditions are getting improved after they like started chatting with Eliza. So in that sense, this kind of personified an intelligent human or intelligent program. So we can still consider it because it is one of the icons. So in this interesting chat, Eliza asked the user, "Is something troubling you?" And the user says, "Men are all alike." Probably the user is a woman. I'm not sure, but maybe. And then Eliza again asks, "So what's the connection, do you suppose?" And the person says, "They're always bugging us with something or other." So to this, Eliza, the program, replies, "Can you think of a specific example?" Then the user said, "Well, my boyfriend made me come here." Eliza said, "Is it important to you that your boyfriend made you come here?" So the person says, "Yes, I'm depressed much of the time." So Eliza says, "I'm sorry to hear you're depressed." And the person replies, "It's true, I'm unhappy." Eliza says, "Can you explain what made you unhappy?" So interesting if you can see a pattern here. Eliza, for the most part, just parrots back what we say, like based on our last response. It creates a new question or a new statement, which are basically combined parts of the previous statement by the user. For example, here the person said, "Well, my boyfriend made me come here." And Eliza basically, like, this is how it works. In step one, it decomposes this, whatever the person wrote, into keywords. And then it figured out, oh, maybe the boyfriend made me come here is the most important part or most important clause here. So it just then figure out, okay, so this is a statement, then it figures out like a question, or it can be other kind of state phrase as well, but it just forms a question with this substituted in right here. Boyfriend made you come here. Or in this case, you're depressed. So, and the person said, I'm unhappy. So unhappy is the keyword. So it just forms a question with the keyword unhappy. So it's not really smart in the sense it is not understanding what the user is saying to the program, but the program is still able to come out with a response which feels natural to the person. So in that sense, it impersonified an intelligent being sitting behind the screen. So that's why it was so popular among the psychotherapists. And it's like an iconic program. And so in 1960s, then a lot of interest came in. ELISA was definitely a breakthrough. And before that, also like people started working on different types of programs to make them intelligent. So Frank Rosenblatt was one of those. He made a like mesh of circuits to replicate how the brains process information and gives the output. So basically, he's trying to make a digital brain, so to say, like the first version of it, which is now is kind of coming back again. So in that, he only had so in the brain we have neurons, and neurons are the processing units in our brain that like make decisions or process input. And then there are synapses that connects those neurons. So he replicated those or emulated those in neural circuits by like having electrical units replacing neurons and the wires as the synapses to process information. So it was a simple circuit, like just one layer, whereas in the brain, there are like very many layers of neurons. So in that sense, this is the beginning, but still it was an approach that was quite bold at the time. And just you can see the wire mesh here that he needs to keep track of or maintain to for this kind of networks. So because in 1960, that was the state of the computer hardware we had. We did not have like very sophisticated computers. So it could still solve many binary classification problem like is the color blue or is the color red, those kind of things, or is it a square or is it a triangle, those things. But it could not still solve many problems that are later found out to be like non-linear programs. I'll come to that later. So anyway, so what happened then in 1960s, the AI, after these movies, then this ELISA, and then some other similar programs that were developed, AI got into like very major hype in the media and in mainstream population. So due to this hype, the expectations soared. But as I said, the computers are not that advanced at the time, and the algorithms were just starting to being developed. So AIs are not that smart, or people probably found out flaws with ELISA and the likes. So, sorry. What happens when there is a lot of expectation and you cannot deliver? People get disappointed, and when they get disappointed, then basically all the interest, all the media hype, all the investment or money that is invested in AI research all go down. So that's what happened since like 65 to 1980. AI research or say development was kind of halted or like slowed down significantly. So that happened, but in I think people say they call it AI winter in AI terms, and then AI spring and AI winter, and then it comes in cycles. So people say around 80 AI winter converted to AI spring when there were new algorithms that came up, which like significantly improved the capabilities of this kind of programs. So one of that like one of the most significant algorithms that basically pushed AI to the next level was called backpropagation. Backpropagation was developed in many different fields prior to that, but this person, Rumelhart, developed it independently for AI domain. So what it did was the Frank Rosenblatt, so just one layer network. It cannot solve very tough, like it cannot tell whether a picture is a picture of a dog or a picture of a cat. Those are complex problems. It cannot solve things like that. So for that, we will have to make neural networks that are many layers deep. And when we have so many layers of neurons, we cannot fix the weights. We cannot hand tune the weights. We need a mechanism to learn these weights. Learn in the sense to tune these weights so that this network can like separate a dog from a cat. And till 1980, let's say, we did not have an answer to how to do that, like how to get those weights. And it is important. So these weights, if we think about numbers, how many combinations these neurons can make, those are in millions, and nowadays it's in billions. So it's impossible to come out with a combination of billion or million numbers that can optimally tell me whether a picture is a dog or a picture is a cat. So we need a algorithm that determines that automatically, and that is what happened in around 1980 when Rumelhart came up with this algorithm called backpropagation. So backpropagation basically allows us to learn weights for a neural network which is many layers deep, and this allowed us to actually develop AI programs that can tell us whether a picture is a dog, cat, human, raccoon, things like that. So those are complex problems. I mean, for human, we may feel like this is not a complex problem because that is what we are doing since we are a few months old, or maybe a few days old. But just thinking about it, how to do that mathematically, it's not easy, right? Can you give me a formula that tell me if it is a dog or if it is a cat? It's difficult to come up with a formula like that. So the computer basically solves mathematical formulas. So it's not trivial. And for us, it is trivial because our brain has been developed for like thousands of years through evolution. So we also do some learning, but not through backpropagation, but through evolution. Like we learn something during our lifetime, our next generation learns new things based on our experience, things like that. So yeah, so finally we have a solution to do something similar in a computer. And so this is the beginning of, I would say, the powerful AI algorithms. No more toy, like things that can be practically used. Well, ELIZA was also used, but it's not intelligent, but something intelligent that can be practically used. And there was this learning-based community or algorithm development going on, which later come out to be like the most more important one. And then the other type of algorithm that were being developed, it was also like non-learning based. And those are kind of, they call expert systems. And this is Edward Feinbaum is the father of this domain, I think. So yeah, so expert system is basically replicating what a human would do in a computer. So a lot of if else in the sense, a lot of conditioning statements. Conditioning. So for example, if I need to decide whether I want to drive a car or I want to walk to a destination. So if the distance is less than 5, I drive. Greater than 5, then I 5 kilometers, for example, then I drive. Or if it is less than 1 kilometer, and then suppose I walk. And then where I want to go. So suppose if the previous decision was I want to drive and I want to go to the city center, then I would take a taxi because in the city center it is difficult to park a car. So I will not drive my own car. So in this scenario, there are like 3 different things. One is knowledge base. Knowledge base is like predefined rules. So if it is 5 kilometers or more, I will drive. So that is knowledge base. Or if it is less than 1 kilometer, I'll walk. That is knowledge base. This is something like we human, when we make decision, this is what our like fixed knowledge base is. This is what we know. And then in this case, the person first decided they want to drive because it is greater than 5 kilometers. And now the other question is whether they want to go to the city center or not. Then the next question is whether to take a taxi or drive your own car. In that case, you need to first, in the working memory, is something like the decisions made prior to the current time. So previously you decided to drive, and now you're deciding you want to go to city center. So in that case, the inference engine will combine the knowledge base that if you go to city center, then you should not bring your own car because parking is high. That is another knowledge base, and a working memory that I'll drive from the previous question. So inference engine will combine those two and then basically answer that to the, if I am going to the city center, I would want to book a taxi. So expert system basically, although it's expert, it's basically imitating the decision-making process of an expert, although these rules that the decision-making uses are fixed. So it's not a dynamic in that sense. It is dynamic because it has the working memory and it accumulates the information over time. I should not say it is not dynamic, it is, but it does not learn. Yeah, so and the major breakthrough, I think, happened in '97 when this IBM developed, so like one of these expert system. So they had a very big, it's a supercomputer called Deep Blue, playing, consuming like many probably kilowatts or megawatts, I don't know, a lot of power, playing versus this person who was Garry Kasparov, the chess champion at the time. And this IBM computer actually beat Garry Kasparov, and Garry Kasparov played it. It's not like he did not play well against the computer, but it was close, but still they won. So that showed the possibilities that is possible with AI or some versions of it, in this case expert system. But the problem is every time Kasparov makes a move, he thinks about 100 different possible moves at max. Whereas the computer with this immense computing power looks at 10,000s or like more, hundreds of thousands of different moves that can be made at every step. So that shows that while this is inefficient maybe, but with AI, we have the capacity to look beyond, because we human cannot see beyond a certain number of moves. We cannot imagine, but computer can do that with given enough power. So that is like an additional dimension that the computer or the AI system have that we do not. This also instill fears that humans may be replacing, AI may be replacing humans, maybe not in chess, but maybe in some other like day-to-day activities which are even simpler than chess. So that was one. Then again, from '97, algorithm development continued, but as I said, for the chess game, IBM has to develop a whole big supercomputer. It's so much money. So it's a lot of, it's not efficient. It's not daily usable, right? So expert system has its limits. It cannot go beyond a certain number of rules because it will be too many, and the computers are not that strong enough because the factorial combination blows up. So the other approach came by, and the algorithms are being developed in both, but this approach seemed to be leading the way at this point. So the other approach is the learning-based approach that I showed previously. sorry, here, back propagation. But at that time, back propagation had two things going on against it. One was the amount of data we had in 1984 was not enough. Like now we go to Facebook or Instagram or like there are so many images we can download with a program. At that time, it was not available like that with like annotation, whether it is a dog or cat or a car. So the data was not there. And secondly, the computers are not that fast. So ImageNet came up in 2010 with 10 million images of 1,000 types of objects. Actually, more objects during training, but for the testing, said it had 1,000 object types. And this, and that by 2010, computers were beginning to get cheaper, let's say, and the computing was beginning to get cheaper. So we can run the computer programs for many iterations or many input data. So that because these deep neural networks or the deep networks need lots of data to train itself. So that was possible by 2010. And that's why I think ImageNet was like a perfect time to develop that, because without computing, it is not possible to develop an AI. So ImageNet happened in 2010, and I think some, I don't know, XRC algorithm, non-neural net based, at that time had an accuracy or error rate of 26%. So error rate in the sense, for example, this is a two-person riding a scooter, and the AI needs to predict whether this is a picture of a human or a scooter, things like that. So, and the ImageNet would have the top 5 categories that this image belong to. So the top 5 are, it is not visible here, but anyway. So the AI in this case would predict the top 5 categories that it thinks this image is. So it predicted, this AlexNet AI predicted motor scooter, go-kart, moped, bumper car, golf cart, all quite close, right? And the motor scooter was the correct one. So yeah, it predicted it with like quite confident. So the red bar is the amount of confidence it had. But for example, in this case, this was a picture of a cherry. And the AI ignored the cherry and focused more on the cat. So, the dog, because this data set was biased for dogs. It had too many dogs. So it actually saw this as a picture of a Dalmatian, I think the breed of this dog. So this AI that was developed in 2012 called AlexNet, it changed the field of AI since then. In the sense that it first, so this is the non-learning thing. So this, for the first time, AlexNet figured out a way to train super deep neural networks using the computing they had at the time. Computing they had, so they were very intelligent in using graphics processing unit, the chips or the graphics cards we use to play video games. They repurposed it to implement this like the layers of deep, like many layers of parallelized neurons in the graphics computers, so that they can be trained faster on these millions of images. And this gave us a new paradigm of how to implement a neural network in computer efficiently, so that it is possible to train it, and then because it needs to be trained for many hundred iterations. Of the whole data set. So, and since then, the use of graphics processor for neural network has dominated the whole field. Now, almost every AI program that is in use uses one of these graphics processor and one of these models. So yeah, you see from 26%, AlexNet brought down the accuracy to 16%. And the human accuracy is about 5. Like there is a person called Alex Krzyzewski, I think. Yeah, he went over the whole data set and classified it by himself. So human, 5%. And now you see the recent ones, ResNet and GoogleNet, even they're newer. So they're even more accurate on this ImageNet data set than the human. So those are I would consider as the kind of evolution of AI, where we started with the imagination of transferring a human body to a robot and to where we are now, and the technology wise. So here I'll just go over some of the current, very notable inventions in the recent years in the AI field, which I think sets the benchmark for where we are headed forward. So this program called AlphaZero from Google company called DeepMind. So they made an AI, this AlphaZero AI, which can, in chess, shogi, go, these are like 3 different board games. Shogi is a Japanese one, and this is played all over East Asia. So, and Stockfish, Elmo, these are rule-based or those expert system-based programs. And AGO is another AI system which beat the best Go player in the world in about 2015. So this AlphaZero, the same program, can play chess, shogi, Go, all 3 by itself. So, and interestingly, AlphaZero does not need any human to train it. It just plays itself again and again and again and again and again. And during this experience of winning, losing, or not doing very well, doing super good, all these different feedback by playing itself, it learns how to play all these rule-based expert systems. So this Stockfish is like the benchmark. This is the top premium chess player or agent or AI program or expert system. And like Elmo or AGO was at that time was the best because it beat the human. And you can see the same AlphaZero program could beat all of those. So this shows, and again, this is from DeepMind. They have lots of resources, computers, I mean, and human to program those. So given enough resources, it is possible to come up with an AI system which is super intelligent on one given task, which is this board game, and it just plays itself. And so this is one aspect. So highlighting more important things in different domains. For medical diagnosis, for example. So this MIT developed this system that can predict breast cancer 5 years before it occurs, based on some like nodules maybe in the radiology scan. So this is another use of AI that has been recently actually changing the medical diagnosis field or overall human health, and it will have like even bigger impact, I believe, in the coming years in how we diagnose or treat our diseases or develop medicines for like diseases like cancer. So in Assam also, for example, we have a type of cancer called esophagus, which is very prevalent. So why don't we do something like that? But yeah, again, for this, the MIT collaborated with hospitals, gathered like millions of radiology scans like this. So yeah, so those are the things. We'll need data and we'll need computer. So, and also human who can program them. So I hope all things can come together for like this kind of problems in Assam as well. And then other like different domain where AI is like dominating. So generating images of person. So this is the person and these are the styles. So this AI is just painting different like portraits of this person with given by this style. So this can eventually become this is already there. Like you can Google like there are lots of apps, Prisma and all. You can just generate paintings of yourself with a given style on your phone, running on your phone. So some actually doesn't run on your phone. Some may run, but the best ones probably run on the cloud, but there's an interface. So this is another way where AI is dominating. It is replacing, for example, artists in a good or bad sense. And in this one, users need to write a sentence. In this case, the sentence or the text is a cross-section view of a walnut, or we call it akrut. So the AI just, these are not real images. They do not exist in the real, like no photographer took these images. The AI generated those by itself based on this text. So another venue where AI recently is getting very, very powerful, which is generating images from text. And this have like many artists worried whether they, the AI can replace them eventually. And something you probably use a lot nowadays, if you go to YouTube or if you go to Google app on your phone, you can just hold on the mic button and then you just say, and the whatever you say, it comes up in the form of a text for Google search or YouTube video search, right? So all that happens in the background in Google servers. Likewise, I'm just saying Google because it's the most used one, widely used. There, like all companies have it now. So they run it in cloud text to speech. So speech to text actually. And this is this is probably making our lives easier. Like when you're riding a bike or you're carrying something in your hand, you cannot type on your keyboard, so you can just use your voice. So this is helpful as well. So self-driving cars, this is work in progress mostly because there is no car yet which is fully self-driving. Human intervention is needed at all time. So at most times. So this is an image from one of the leading companies in this field called Tesla. So how Tesla solves this problem? It in the first stage, it divides it in the scene into like roads versus cars versus pedestrians with bounding boxes, and then and recognize where it is. So it's called localization. And after localizing, it plans the route. Suppose I want to go from Khanapara to, I don't know, Poltan Bazaar or in Guwahati, I mean. Then it will plan like overall, I have to follow this route. And then this is like the long decision making of the route. Then in short decision making could be whether I overtake a particular like slow vehicle or not. That could be like a short-term decision. And then finally, some other AI has to determine how much of the brake needs to be applied, how much of the gas or the accelerator needs to be applied, things like that. So it works in stages and all running at the same time. But currently, in the state of this research is not foolproof, so we probably still have some time to go. So, oops, sorry. We have a few, I'm hoping we can do this. I have talked to the other lecturers. So I have planned few more talks in this series. So this was just an introductory talk about why we should know about AI and how, because it will change our lives, like Professor Nath said. So it will change our lives, and how we can embrace this technology, and instead of just relying on some companies to build stuff for us for like in the context of some. I actually missed one. Oh, sorry. Okay, I had one more, but did not come up here, I guess. Anyway, so I wanted to show one more demo of a chatbot that came up recently called ChatGPT, and in the last week, people all over the world has been going crazy over it because it can, like Elisa, you saw, it did not understand anything what the user was saying, but the ChatGPT does. You try to trick it, but it still understands. It is trying to trick you. So so you can ask question if you ask question to ChatGPT like, how do you break into someone's house? So then ChatGPT would not give you, you should bring a hammer and break the lock. It will not answer like that. It will say you should not break into someone else's house without their permission, things like that. So one of the major theme in AI is to being responsible now, because AI can be used for good, AI can be used for bad. So the bad part is worrying, because like you just saw the image generation. What if I generate an image or video of you murdering a person, or like doing some bad things? So that may be possible already. So we need to have some sort of way to detect whether a video is fake or whether a video is not fake, real. Or for example, whether a prediction of breast cancer, if it is accurate or if it is not accurate. We do not want like a surgery which is false. So we need so that is about accuracy, but this other aspect is about like ethics, whether the AI is doing something good for the human or doing something bad for the human. So we need to be careful about that. So the ChatGPT, so initially they made a chatbot, the same company called OpenAI, but the chat was not how to say, it was not ethical. If you ask how to break into a house, it will tell you all the answers, like bring a hammer, like break the lock and things like that. But the new ChatGPT, it is trained with human feedback. So when it initially it gave this kind of answers, but the humans then give it feedback. Oh, you should not do that. You should not break in. So things like that. So due to this human feedback loop, it tried to come up with responses that are ethical to our societal standard or to like civilized society. So that is another aspect. So I hope Professor Jugal Kalita, who works in natural language processing in University of Colorado, he will shed some light in those aspects as well. So I'm expecting a lineup of talks. First, on January 8th, Tiffany Hu, she works in a gaming company. So, and she works in robotics also, like virtual games, as well as she also used to work on physical robots. So, yeah, she will give a talk on how AI has been recently used in robotics domain. Then I'll talk about machine vision domain, which is not recent, in the last decade transformed by AI, including the self-driving cars that I just briefly talked about. I'll go into detail. And then Jugal Kalita can go over like natural language understanding. And he has also done a lot of work in understanding Assamese text and generating Assamese poems and things like that. So really fascinating. I hope you all can come to those lectures as well. So without further ado, I think I'll stop here for today. I hope you got motivated enough to invest some of your time, either as part of your curriculum, may not be part of your curriculum, but just an overall interest. Maybe watch one of those movies, Metropolis or other, where they showed intelligent robots, or read about the recent developments that I just mentioned, or maybe try ChatGPT. It's free. So then hopefully it will, in Assam or in that domain, will create more interest in the AI domain, and people invest, or students or colleges invest more time into that. So that's my hope, and I hope you enjoy these lectures in the coming week, the next months. Thank you.
ধন্যবাদ হিৰক, বৰ সুন্দৰকে তুমি আজি AI মানে কৃত্ৰিম বুদ্ধিমত্তাৰ বিৱৰ্তন আৰু সাম্প্ৰতিক ধাৰা সম্পৰ্কে আমাক ব্যাখ্যা কৰি দিলা। আমি আশা কৰিছো যে এই অনুষ্ঠানত উপস্থিত থকা সকলোৱে ইয়াৰ পৰা উপকৃত হৈছে। গতিকে 15 মিনিট শিক্ষাৰ সমূহ সদস্যৰ হৈ মই তোমাক আন্তৰিক ধন্যবাদ জ্ঞাপন কৰিছো। আৰু আমি পৰৱৰ্তী অনুষ্ঠানসমূহলৈ আশাৰে বাট চাই ৰম। ইয়াত উপস্থিত থকা সকলোৰে জ্ঞাতাৰ্থে জনাও যে আমাৰ পৰৱৰ্তী অনুষ্ঠান আসলতে 25 তাৰিখে আমাৰ বৰদিনৰ কাৰণে অনুষ্ঠান প্ৰচাৰিত নহব। তাৰ পিছত জানুৱাৰীৰ 8 তাৰিখে 2023 জানুৱাৰীৰ 8 তাৰিখে আমাৰ পৰৱৰ্তী অনুষ্ঠানটো হ'ব। তাত বক্তৃতা দিব টিফানি হু, AI in robotics। হিৰকে ইতিমধ্যেই কৈছে। আমাৰ আজিৰ অনুষ্ঠানত দুখন সহযোগী কলেজ, সহযোগী মহাবিদ্যালয় আছে। সেইকেইখন হৈছে SB দেওৰা কলেজ আৰু জাগিৰোড কলেজ, SB দেউৰা কলেজৰ অধ্যক্ষ ডক্টৰ ধৰ্মেন্দ্ৰ নাথ আৰু জাগিৰোড মহাবিদ্যালয়ৰ অধ্যক্ষ ডক্টৰ ভৱেন চন্দ্ৰ নেওগক আমাৰ তৰফৰ পৰা আন্তৰিক ধন্যবাদ জ্ঞাপন কৰিছোঁ। আজি শিক্ষাৰ্থীৰ উপস্থিতি অলপ কম। আমাক কোৱা হৈছে যে শিক্ষাৰ্থীসকলৰ সেমেষ্টাৰ পৰীক্ষা চলি আছে, সেইকাৰণে বহু শিক্ষাৰ্থী আহিব পৰা নাই। হলেও কিছুমান মহাবিদ্যালয়ৰ পৰা কিছু সংখ্যক লোকে হয়তো ফেচবুক বা ইউটিউবৰ জৰিয়তে এই অনুষ্ঠানত অংশগ্ৰহণ কৰিছে। সকলোলৈকে আমাৰ তৰফৰ পৰা ধন্যবাদ জ্ঞাপন কৰিছোঁ। আৰু এতিয়া আমি আহিছোঁ ইয়াত চেট বক্সত হয়তো কেইটামান প্ৰশ্ন আছে, সেই প্ৰশ্নসমূহ আমাৰ অনুষ্ঠানত উপস্থিত থকা 15 মিনিট শিক্ষাৰ সদস্যসকলে হিৰকলে আগবঢ়াই দিব পাৰে আৰু হিৰকে সেইবোৰৰ উত্তৰ দিব পাৰে। আৰু আপোনালোক উপস্থিত থকা জুম প্লেটফৰ্মত উপস্থিত থকা অংশগ্ৰহণকাৰীসকলে পোনপটীয়াকৈ আচলতে হিৰকক AI ইভলিউশন আৰু কাৰেণ্ট ট্ৰেণ্ড সম্বন্ধে প্ৰশ্ন সুধিব পাৰে। ধন্যবাদ।
ধন্যবাদ sir.
Thank you, Hirak, for this very informative and illuminating talk. And there is one question I can see from Bubul Saikia, so who wants to know if there are some reputed institutions in India where one can study AI.
Yeah, there are. I think definitely we have so many good engineering and technology institutes. So I think those are good. So I should not rank or mention someone or leave someone, but in general, I think IISCs, IITs, or engineering colleges, everywhere where you have a good enough computing resource and like some person who is like professor or like the department who is conducting research in AI should be good. Personally, I know some research groups in IISC Bangalore to be really good in natural language processing, and also in IIT Kanpur. In vision, computer vision field, or in IIT Kanpur had many groups actually, which are really good in different like algorithms development and all. But yeah, that is yeah. But beyond that, I don't know specifically. Like this institute is really good, but yeah, so I think the easiest way to know whether an institute is good for AI or not is now all institutes have their websites. Or universities, you can just go to the department. If they have an AI department or computer science department, you go to the website and see who are the faculty members there, and if they're doing AI research for like last 10 years and what kind of research they're publishing, you can easily figure out that. I have not done that myself, so it's hard to say. I'm just mentioned a few departments that I have read papers or I may have met people from, but there are definitely other departments that I clearly did not mention who might also be really good. So yeah, I think that is the approach. Go to the website, see what AI research they have done, and if you see a lot of good papers, good in the sense published in established conferences and things like that, then or journals, then they should be good.
So Hirak, actually in today's lecture we have a few doctors as well, and there are a couple of pathologists whom I know they have joined. There is one question from Nabanita, who is in Guwahati actually, so she's a pathologist. So her question is AI education for someone from medical background and its applications, possibilities, scope. So I mean, Hirak, you want to say something? We can also add to that little bit.
Oh yeah, yeah. So I personally have not worked on like medical, like radiology or pathology data as an AI application. But yeah, it is a very big, like a booming field now. So there are a lot of researchers working. So to answer the question, if there's an education there, I'm pretty sure there will be many like free Coursera courses or like other online MOOC courses on that uses those kind of data using some public data set. But I have not done it myself. Maybe Rifadda has some plans to add like an expert in that domain.
No, thank you, Hirak. I'm not an expert in AI, but for Nabanita, I can tell you that actually in pathology, for example, like I can talk about that little bit. So the AI is definitely, coming up, and it is still in the early days. But there has been a lot of progress or a lot of recent developments in AI and pathology. So, and for those people who are not in pathology, I can say that basically how in pathology world AI can be used or is used is that in pathology we recognize patterns and try to diagnose a disease. So that is how, like, I mean, human mind is able to diagnose a disease. So, but AI can be trained to recognize those data and diagnose disease. So in fact, towards that end, there has been a lot of developments in the US and other parts of Europe and other countries too. So that prostate cancer is one, for example, in which already, like, I mean, an AI algorithm has been approved by FDA that AI can be used to diagnose prostate cancer, so that, like, you don't have to, but for that there needs to be a lot of, like, I mean, other things that you need but still, that is one thing I can say. For example, there has been a lot of developments and there has been research which has been published that you can diagnose metastatic breast cancer, in lymph nodes by using AI, and some many other fields as well. And so definitely it has a lot of scope. And someone has added on the chat box, Sandhya, that the PEPNet for cervical cancer screening. So in medical field and in pathology and in radiology, a lot of fields, like, I mean, AI is coming up. So, I mean, there has been a lot of
regarding
progress.
the education, are you familiar with like some course for like
course, actually, I think I'm not very sure if anyone else in the group has idea. Maybe like MIT has some courses, or maybe Coursera will have something online. There should be some online courses available. I mean, if you want to, like, there are a lot of startup companies for AI where, like, I mean, in pathology also AI is being used. But, like, for example, there is a company called Path AI, and there are others also, but they don't usually teach, but one can learn from them, I guess so.
I think
And for
Rifat
I don't think that there is a
lost
fellowship
the connection, right? Looks like.
Sorry? Someone said something. If anyone from the audience wants to add, so feel free to add. If someone can give some more information.
Hirak, মোৰ ফালৰ পৰা এটা প্ৰশ্ন আছে।
Hello.
Hirak. Yes. কওক।
নাই মোৰতো একো AI তেনেকুৱা কোৱেশ্চন নহয়, মই তোমাৰ একদম আৰম্ভণিৰ পৰা শুনিলো, ইমান সুন্দৰকে ব্যাখ্যা কৰিছে। দুটা আলফা জিৰা মেচিনে যদি if they compete each other, play chess each other, so will there be a winner or loser?
If it so it plays itself, so it can be either winner or loser during training.
Two different machines.
So
two different machines having the same program. So if they play each other.
So it can either lose or it can either lose or it can either one, only one will win the game, right? So one isn't has to win and the other isn't has to lose.
Why one will win and the other will lose?
I mean, that's how the game is, right? In chess, only one player wins.
No.
So
They
suppose
are
you replicate the program and make 2 instances of the program only, and then they play against each other. The
that
program.
means one of the machines will make a mistake.
Yeah, and in the beginning they just make random moves, okay, random valid moves, but then one will lose, the other one will win, and the one that lose, the training algorithm will tell that program that will not follow that program anymore. It will follow the other program that made the correct, that won basically. So that's how the training happens. So the training happens by making mistake, and যেতিয়া mistake হয় তেতিয়া error to calculate হয় কি ভুল কৰিলে, আৰু সেই error to, so that the program আকৌ error to repeat নকৰে next time, the training algorithm changes the program so that the program does not make the same error again.
But the third one, if there is a third one, so can you tell which one will lose or which one will win?
Oh, I don't know. I think during this development, so at the end of the training, they had only one program, like that is the fully trained, okay? So these 2 program thing I'm saying, it is only during training. So in the training, since chess is just 2 players, that's all you need, or the other like Go. So yes, so there is like no 3-player scenario at a time.
Okay.
So it depends, but I understand your question, but it's not like this training program or training paradigm is just limited to chess or Go. It can be applied to some 3-player program, maybe. Then yes. For example, the imitation game by Turing, where there were 3 players. So the AI can be all 3 players. So in that case, yeah, that could be a training paradigm. But yeah, it's overall, it depends on how the gameplay is.
Okay. But one more, just just one more. So if there is a completely new virus or something completely new for which you do not have any data, then this AI can detect it.
Which AI are you referring to?
No, any AI. I mean, this alpha.
Yeah, by itself. During training, it cannot. Sorry, the AI algorithm. So these are data-driven AI.
Okay.
So they learn from what data is showed to them, like. So, and they believe that the data is correct, or we call it ground truth. So if the data is misleading, then the AI will also learn misleading things. But if you're now like the ChatGPT that I did not show, but I talked about whether if you can, if you try to trick the chat machine, it recognizes if it is an ethical question or unethical. So in that case, the program was trained to detect those kind of tricks. So yeah, during training, it is possible to make the AI recognize whether something is true or false. But that requires more human intervention during training.
Thank you. Can I add a little bit on this, actually, sir? That is the flip side in medical field also. Like, I mean, that you have to put data to train the AI or to develop an algorithm. For example, we are developing an algorithm to detect cancer in the pathology slide. So then there has to be a lot of data on how to diagnose prostate cancer into that algorithm. So in that process, if someone puts wrong images, because like the AI needs to be trained, if wrong images are put to the algorithm, then when the final product will come, so there can be mistakes. So that is a flip side where we need to be careful. And as Hirak said.
Okay, the data, understand that it is a data-driven AI, data-driven. So you have to have data. So that means, so there is no chance that AI will someday invent some new theory.
Invent some new theory.
No sense.
AI can already invent theory. It's just that whether the theories are useful or not, I guess. But not all theories for sure. But no, yeah, it can already do that. I mean, you can ask this ChatGPT machine, give me. It depends on what do you mean by theory. Are you like the complexity of the theory? It can probably already do.
No. I'm not about asking about the complexity. I am asking about the completely new theory. So about which any scientist or nobody had any say clue. No data for any theory. For example, Einstein developed the general theory.
I'll not say never to anything. Einstein, yeah, so that's a different level, I guess, of complexity. But I'll not say never, because sometimes not just AI. Sometimes when you like how to say analyze data, you come up with theories that people did not think of, like some sort of maybe correlation. Some sort of correlation, for example, to very unrelated metric that no one ever thought of. But by analyzing data, we can like detect those kind of patterns, or you can also call that theory, that this variable is related to that variable, which we did not thought of before. So that is also a theory in a sense. So
Yes.
I think it is possible in that sense, but not everything. Yeah, and like we said, not everything it comes up with it may be true. I mean, even the first program I saw, logic theorist, it could come up with proofs for this Principia Mathematica, the questions in Principia Mathematica, and gave explanation for those proofs. So yeah, so there are limits. Of course, it cannot do everything, but yeah, it can, I think, already do something, and going forward, it will be solving even more tougher problems.
Okay, thank you, Hirak. Thank you so much. So, what it was an excellent talk. Okay, Hirendra, you can go ahead.
ধন্যবাদ ছাৰ। হিৰক, মই তোমাক এটা প্ৰশ্ন সুধিব খুজিছোঁ। অলপতে ছান ফ্ৰান্সিস্কোত পুলিচৰ সলনি, মানে হিউমেন বিঙৰ সলনি ৰবট ব্যৱহাৰ কৰাৰ কথা, পাব্লিক মানে জনসুৰক্ষাৰ কাৰণে ব্যৱহাৰ কৰাৰ এটা প্ৰস্তাৱত মানে ভোট দি ৰাইজে নাকচ কৰিলে প্ৰস্তাৱটো। কিন্তু ৰবট ব্যৱহাৰ কৰাৰ কথাটো প্ৰস্তাৱটো ওলাইছিলে, আৰু ৰবট ব্যৱহাৰ কৰাই নহয়, তেওঁলোকক ডেডলি ৱেপন দিয়াৰ কথাও ওলাইছিলে, যে তেওঁলোকে অস্ত্ৰ শস্ত্ৰ লৈ ৰাস্তাত টহল দিব, আৰু মানুহে বেয়া কাম কৰিলে বা দুখ কৰিলে সেই ডেডলি ৱেপন বিলাক ব্যৱহাৰ কৰিব পাৰিব। এতিয়া মোৰ প্ৰশ্নটো হ'ল যে AI বা ৰবটছৰ যিটো এতিয়া সাম্প্ৰতিক ধাৰা বা বিৱৰ্তন হৈ যিটো পৰ্যায় পাইছেগে, সেই পৰ্যায়টোত আমি মানুহে আমাৰ সুৰক্ষা ব্যৱস্থাৰ সম্পূৰ্ণ দায়িত্ব ৰবট বা কৃত্ৰিম বুদ্ধিমত্তাই ল'ব পাৰে বুলি বিশ্বাস কৰিব পাৰোনে?
মই ভাবো নোৱাৰো এতিয়াও বিশেষকৈ
one quick question, Hirak. Actually, we have I think maybe one or two people in the audience who may not understand Assamese, so maybe you can answer in English for them if you don't mind.
Okay. Yeah, so Hirendra sir asked me that recently a city in USA called San Francisco, they implemented they proposed, I think, and accepted an idea to use a robot army which can use lethal weapons, like as a complement or additions to their police force. So is it ethical, or is it so Hirendra sir asked me whether current state of the AI allows that kind of use, or it is not there yet. I personally think it should not be used for those kind of uses yet, because first of all, there is a like this biasness in training is like just we discussed is already there. So it might not, suppose there is a person from Bhutan, let's say, wears a particular kind of attire. Okay, he comes to San Francisco. This AI has never seen a person wearing that kind of dress because the data set did not have it, for example. So it might just identify that person to be an anomaly, or like, so that is kind of biasness in data set. That is one aspect. Secondly, a lot of social, like when the police intervenes a situation with like couple of people, there are like a lot of social interaction that goes on. Social in the sense, you need to understand the context. Suppose a person hit another person, you need to know why the person hit, because is the person trying to rob, is person one trying to rob person two, or is because person two stole something or stole the key to person one, that's why they are hitting. So they need to understand the whole context. And the AIs cannot be trusted with understanding, because most of the AI currently, they're so complex that it's hard to understand why they make a particular decision. People call them black box, meaning, although they are not, but people call them black box because it's hard to explain why AI made a decision. So in this case, if the robot, suppose, uses a lethal weapon, we will not have any explanation of why the AI used it. Like any, it will have explanation in terms of numbers, like a list of numbers, but it will not have an explanation in terms of this person did that because of that. I used a lethal weapon. The AI, in many cases, may not be able to give an explanation like that. So convincingly. So unless we receive a state, and in any sense, I think there are other ways to use AI in like surveillance and security than using a weapon, I guess. And like maybe the AI can just inform the police about a suspect or things like that, or like detect suspect, like a possible suspect based on behavior, things like that, and inform the police. That kind of like passive and like not passive, like behind the scene involvement is possible at this time, which is good and bad. That means it is, I think, already there in China. The government always keeps track of what you're doing, like in the road, are you driving too fast, things like that. So or some other countries, I don't know. So that is already there. So that removes you from civil how to say, your freedom or liberty to live your private life, because someone is always looking what you're doing. So a lot of issues. So I already mentioned about like the biasness in training data sets that can lead to some like problem in some situation, and the problem with understanding the context or the human interactions is a problem. Then the problem of privacy, and like we do not want to be looked at by a robot or a camera all the time. And the problem of explainability, why a robot like used a lethal weapon. We need to have like a clear explanation from the AI to actually use it. So all those are still not like 100% proof. So at this stage, like Rifat said about pathology, even though AI is used to predict, but that is always verified by a doctor. In this case, I think it should not act by itself independently, but rather work as a help to the policeman. And I think currently it is not in that state. And going forward, it's hard to predict that it will be 100% sure proof that it is making a correct decision. But in going forward, it may be less biased, because now people are putting a lot of efforts into gathering data set that are not biased, that has like same amount of white people, same amount of black people, same amount of Indian, same amount of Chinese people, for example, so that all people gets equal representation. So the biasness will be gone to some extent, because now people are putting money into that. And explainability will also be solved to some extent, because again, now algorithms are designed that just not only just predict the action, like use a weapon or not use a weapon, but also to explain why it arrived at the decision. So algorithms are being developed to do that. So I think explainability will also be gone. Accuracy, suppose we have like really trained a really good, like the image classification, the AIs are better than human. It is possible to, it may be possible to make an AI which is even more accurate than like a police officer in making decision. That's possible, given all these good scenarios. But one thing that will still not be there is the privacy. We do not want to be looked at by a robot or a camera. That is not going to change. I guess, but you never know. People sometimes really love some technology and embrace it, but I feel people don't want to be looked all the time by a robot or a camera. So because with this kind of a robot, if they use a robot, so now they have a limited number of police force. And if the robot comes into being and it gradually becomes cheaper, they can just put like a flood of those robots everywhere. And people, I don't think I like to be like surrounded by this kind of robot police everywhere all the time. So yeah. So current state, I don't think it is possible to use that. Going forward, it may be possible, but people may not like it.
Hirak, my attack question, I want to ask you a question on in terms of solution. So I used to do demand forecasting, and the problem was like demand forecasting, our main drive, our input bilak asil, our main inputs were previous demand, but during COVID that has completely changed. So after that, like it was really difficult for us to like use the same like model based on the data. Like we needed a lot of human intervention, and and machine learning model did not work. Like we had to do a lot of massaging because we don't have that kind of data. So the problem is, what I heard is either you have to put like good data, or you have to put very sophisticated algorithm. But the problem with sophisticated algorithm, what we say, we don't know what are the inputs they have taken to judge the decision. So we face that kind of a problem. So now I am working with another problem. So I move to a different industry. So now what happens, like we get a lot of customers who wants to go to space, and not everybody can go, right? So and also we have to market to those customers which actually can go, like pay that much money, like millions of dollars, right? But we get a lot of requests, so we have to remove people who are actually interested, who are capable of going. And we have to forecast that and tell the marketing people like this is the budget and you have to do that kind of stuff. So do you have some good solution? Because the problem is this is a very new industry and we don't have much data, and we don't have much data in terms of measuring the accuracy because we don't have an use case. So since we don't have good data, we have to rely on good algorithms. So what do you think, like, what is the possibility of AI in that? Like,
so that is a problem called recommendation problem, a recommender system. So so those are usually data based, based on like statistics based on what they wanted. So which people, for example, in case of space scenario, what is the average income of the people that actually went to space in the past? I mean, bearing the scientists and astronauts who were sent by NASA, for example. I mean, as a tourist, like recently, a lot of companies are launching tourists. So, yeah, when the amount of data is not enough, I think, yeah, you should.
No data, just think of there no data. So, what is the?
Yeah, so if there is no data, you cannot use, suppose, a learning-based model, because learning-based model learns from data. So I think without data, expert systems based on human knowledge is the way to go. And as you gather data, then you can make a hybrid model combining learning-based and expert systems. Expert system is the old traditional AI, like rule-based. So rule-based system, like the trivial can be designed either with hand or maybe with a decision tree. But yeah, again, for any kind of automated development of those kind of recommender system, you'll need data. So without data, I think expert systems with like rule-based programming is the possible solution.
Okay. Thank you.
I think we have come to the end of the session. So, aru jodi prashna nai, then we can end the session or we can conclude it. Aru karbar kiba prashna ase niki baru? Jodi nai, then Hirakok Oshesh dhanyabad janaisu for this very educational, informative talk on this topic, and which is fast evolving. And
Rifat,
sorry.
I'm sorry to interrupt you. There I see an hand, Cecile.
Oh yeah. Yeah, please.
Oh.
Sorry, please go ahead. Shishir, you want to ask something? I think you are unmuted.
ধন্যবাদ স্যার হেল্ল'
কওকচোন
হেল্ল' হয় হিৰক টকটো বিৰাট ভাল আছিলে মানে ইণ্টাৰেষ্টিং আৰু প্লাছ মানে বিৰাট ইনফৰ্মেটিভ মোৰ কুৱেশ্যনটো হ'ল এইটো যিটো আপুনি বায়াছৰ কথা কৈছিলে মানে ট্ৰেইনিঙত এতিয়া আমি যদি চ্যাট জিপিটিৰ কথা কওঁ নতুনকে যিটো ওলাইছে অপেন এআইৰ পৰা এইটোত মোৰ প্ৰশ্নটো হ'ল যে আমি যেতিয়া এটা মডেল বনাও ঠিক আছে মানে ধৰক যিকোনো মডেল আজিকালি যিবিলাক মানে ডাঙৰ ডাঙৰ লেংগুৱেজ মডেল বা ভিজন মডেল বনাই আছে সেইবিলাকত ডাটাবিলাক ডাইৰেক্টলি ইন্টাৰনেটৰ পৰা মানে কালেক্ট কৰে ঠিক আছে এতিয়া কথা হ'ল ইন্টাৰনেটত কোনে লিখে ইন্টাৰনেটত মানে লিখো আমি মানে হিউম্যান বিইঙে লিখে তো ইন্টাৰনেটত যিবিলাক কথা থাকে সেইবিলাক হয়তো কিছুমান ভাল কথা হ'ব পাৰে বা কিছুমান বেয়া কথা হ'ব পাৰে এতিয়া আমি ধৰিলো কি আমি ভাল কথাখিনিয়ে লৈছো বাৰু যে যেতিয়া মডেলটো বিল্ড কৰিবৰ কাৰণে
হেল্ল' তোমাৰ ভইচটো মিউট তুমি আকৌ মিউট হৈ গলা নেকি সুশীল
হেল্ল' হেল্ল' হয় সৰি হয় তেতিয়া কথা হ'ল এতিয়া যেতিয়া আমি হেনেকুৱা মডেল বিলাক বনাই ডাঙৰ ডাঙৰ কোম্পানী বিলাকে তেতিয়া কিছুমান প্ৰবলেম আহি যাব পাৰে যেনেকে মানে ধৰা হ'ল আমি যেতিয়া চ্যাট জিপিটি মানে চ্যাট কৰো মই এটা সৰু এক্সাম্পল দিছো আৰু মানে হেতু হ'ল আমি যদি এটা তেওঁক কওঁ যে মানে চ্যাট জিপিটি ৰাইট এ প্ৰগ্ৰাম টু write a Python program which can show মানে average মানে salary to বা এটা এজন এমপ্লয়িৰ মানে salary to predict কৰিব লাগে ধৰা হ'ল তো আমি যদি তেনেকুৱা এটা প্ৰগ্ৰাম আমি চ্যাট জিপিটিক লিখিব দিও বেলেগ বেলেগ এক্সাম্পলস মানে মই যেটো দেখিছো মানে তাত কেনেকে আহে তাত মানে আমি যদি দিও কি ইনপুট বিলাক যদি আমি জেন্ডাৰ লও প্লাস মানে আমি নাম্বাৰ অফ ইয়ার্স অফ এক্সপেৰিয়েন্স লও আৰু ৰেস টো লও তো তেতিয়া কি হয় তাত ফিমেলক ওয়েটেজটো কম দিয়ে ধৰা হল মানে আমি ফিমেলক 0.9 ওয়েটেজ দিলে বা মেলক 1.1 ওয়েটেজ দিলে তো এতিয়া কথা হল আসলতে হেতু হ'ব না লাগে কাৰণ জেন্ডাৰ বেসিছত কেতিয়াও মানে আমি স্যালাৰিটো নিৰ্ভৰ নকৰে জেনাৰেলি এতিয়া কথা হল হে যেটো বায়াস তাত এড হৈছে চ্যাট জিপিটিত হেতু হৈছে কাৰণ আমি হয়তো আমি তেনেকুৱা মানে আমি হিউম্যান বিইং তেনেকুৱা যে আমি ফিমেলক বেছি ওয়েটেজ দিছো during the employment issues তো সেইবিলাক কেনেকে এড্ৰেছ কৰিব পৰা যাব কাৰণ আমি যদি ইন্টাৰনেটত সাৰ্চ কৰো কি ইন ওয়াৰ্ল্ডত মানে ওমেনৰ এমপ্লয়াবিলিটি কিমান তেতিয়া হেতু এৰাউন্ড মানে কম হয় এৰাউন্ড 13% বিলো মেন হয় তো সেইবিলাক বস্তু কেনেকে এড্ৰেছ কৰিব পৰা যায় মানে
Yeah, thank you, Sisir, for the nice question. So Sisir asked me about ChatGPT. So he tried ChatGPT and like asked it to write a program that can predict a person's salary based on gender, age, I guess education, things like that. And he saw that there is a biasness towards the women when the gender is women, that the salaries, predicted salaries are lower, or the program that ChatGPT wrote predicts lower salary for women. Sorry. So yeah, so that is how to say, that is I would say not the bias with the training, but that is a more bias with the society, and maybe that is real. Maybe in the society women are paid less than men, and I'm not sure if OpenAI like employed humans to like manipulate suppose the salary numbers in some text they used to train. But if they suppose did not suppose they had the correct data for training, I would still assume 13% low salary for women than men on average is probably how to say, it's unfortunate, but that is probably the case, because not only in US, also in India, I think women maybe did not get enough time to study, go to college. Like many women get married soon, or some like get involved in the family, kids and upbringing those kids and stuff. So they do not probably maybe do not get enough opportunity to how to say, go up the ladder, and or maybe they were biased or discriminated against in their work at their workplace because of some preconceived idea, like you said. So all that happens in real world, and the overall effect is that women get less salary. So in this case, I don't think if ChatGPT program is predicting 13% less salary on average, that may be realistic. But in other cases, yeah, there can be things that are not representative of the real world. There can be things that can be misleading. Suppose the other way, suppose we are training ChatGPT to make a program that predicts women get 13% more salary. That right, but that will that will be unrealistic. So there are two things. One is biasness in society, independent of AI or whatever. But the other thing is the sorry, the biasness in the training data, whether the training data is a good representative of the real world or not. So when training AI, we need to make sure that the AI is a good representative of the real world. And at the same time, it also needs to make sure that these bad things in the real world are not taught to the AI to to predict or to suggest, right? Like bad things people say online all the time. The chat should be, it's not like we do not feed those input at all to the AI. We need to feed those so that the AI need to recognize that these are bad things, and I should not say those to the user. So we need to give a good like good proportionate representation of the real world, and also tell the AI what is good and what is bad, so that it can make that decision. So I think that's the right way, instead of manipulating the data itself.
হয় ধন্যবাদ স্যাৰ যদি 1 মিনিট সময় আছে আৰু এটা প্ৰশ্ন সুধিব পাৰো
মোৰ সময় আছে কোৱা
হয় আৰু এটা কথা মানে যদি আমি ভাবো কি মানে এনেকুৱা ডাঙৰ ল্যাঙ্গুৱেজ মডেল বিলাক ৰিয়েল ওয়ার্ল্ড মডেল কৰে তেতিয়া হলে আমি এনেকে উল্টাকে ভাবিব পাৰো নেকি যে মানে যিবিলাক ৰিয়েল ওয়ার্ল্ড প্ৰবলেম হয়তো আমি ষ্টাডি কৰিবৰ কাৰণে ডিফিকাল্ট হয় মাইনত লেভেলত সেইবোৰ হয়তো আমি থ্ৰু তেনেকুৱা ধৰণৰ মডেল বিলাকৰ থ্ৰুৰে আমি ষ্টাডি কৰিব পাৰো নেকি মানে কিছুমান সোশ্যাল প্ৰবলেমছ হয়তো
I think so. Yeah, social problems were. So yeah, Shishir asked me if we can. There are so many social problems that we have not solved yet. Can we use AI to solve? Yeah. So depends on the social problems, I guess. Some problem, for example, in India or in Assam, not everyone gets the same opportunity to good education, for example, not every student. So yeah, we can use AI to basically an AI program that works as a teacher, like a history teacher or a mathematics teacher. And that is available all on like Android devices or like phones or tablets or computers that can be developed, and that is a social problem that we have in Assam or in India that we can solve with AI to some extent. I mean, it is always better to have something than nothing, and it might be better than many like other human teachers as well. It's possible. And then there are some like disease diagnosis. Many people for example, the breast cancer is like you need radiologists. There is skin cancer. So there is a university here, Stanford University. A group in there developed a skin cancer detection app using AI. So you just take your phone, take a photo of your skin, and it tells you whether the skin is cancerous, like if there is a mole, if that is cancerous or non-cancerous. And actually it can predict that with higher accuracy than the human doctors that they tested against, because it's sometimes like many years ahead, it's hard to predict, I think. Anyway, so then the data probably Stanford used is not a good representative of the like the skin color or skin cancer conditions in Assam, right? I don't know. I have not looked at the data, like where they collected it from, but probably not. No, probably not like a good representative of the people in Assam. So definitely, if we can develop something like that for targeted towards that particular society where the diagnosis is very costly to many people, that can be another societal problem that can be solved. And like then there are like complex human to human social problems. I don't think AI can give a solution for that. We have to find a solution outside of AI.
ধন্যবাদ
No, thank you. Actually, I can just add a little bit, just one line is that, I mean, you have to, definitely AI is going to shape the future, and there is, whether you like it or not, that is what is going to happen. But I mean, you also always have to like keep it in mind, as Hirak has been mentioning all the time, is that the human intervention. So it doesn't make human mind or the human brain irrelevant. So it will help human brain or human intelligence quite a lot. For example, in the medical field, doctors will not become irrelevant. So that is always the fear, even among the medical community, that if AI is developing fast, will the doctors become irrelevant? If, for example, in pathology or radiology, if we have AI in making diagnosis, then will our jobs go away? That is actually not going to happen. And as we have discussed during this talk, there are many things where human intervention is important, because when we make a disease diagnosis, we just cannot look at the image and make the diagnosis. We have to look at the patient as a whole. What is the patient's problem and what are the other things that the patient is having? Then you make that diagnosis. So for that, you will always need a human mind to make all those combinations, and those cannot be replaced by data alone. So I don't think like that it will totally replace, and there will always be a human element which will actually need to control and regulate AI if we have to make AI like more human friendly in the future. So that's I think it is still such an early stage in development of AI, right? So there's a long way to go, but it is unavoidable.
Yeah, I think gradually the AI will become more, how to say, human-like, but at this time, yeah, it will not a sudden change.
Yeah.
And also depends on the application, right? If it is deciding whether a person has cancer or no cancer, that is more like a critical thing. It's hard to replace human, but suppose AI generating music or a poem, there like no one will die if a poem is not good.
Right.
So you can use that AI for like, so those things will be replaced sooner. Like that's unfortunately, but yeah.
No, like, I mean, Hirak said something very important, that a same AI program which was developed in the West to diagnose skin cancer may not be applicable in India. The same reason is that because of the skin color. I mean, there might be a lot of other conditions which are there in patients with darker skin color, which the AI will not detect. So those kind of things will also be important in that, like the human brain has to use, and we cannot just, I'm just giving a small example, that we cannot totally and blindly rely on AI in the future.
Yeah, and also I feel that data behind which is used behind AI is very important, and that part also should develop equally hand in hand. Like even now that lot of data, like database fail, I know you don't get good data, so there has to be a lot of innovation in that part also for AI to work accurately.
Right. So,
Right, yeah.
So I think আমি মানে এইটো programmer অনুষ্ঠানৰ সামৰণি মাৰিব পাৰো এতিয়া. Thank you again, Hirak, for your very, very informative and engaging discussion on this very evolving topic. So আৰু আকৌ ক'ব খুজিছো যে we will have a series of 4 talks. 4টা lecture হ'ব artificial intelligence ওপৰত. আজিটো প্ৰথম, and second lecture is on January 8, in which Tiffany Hu will present on robotics. So maybe you can have you can add a line on Tiffany Hu. Hirak, can you add one sentence?
Yeah, so Tiffany Hu, she went to UC, University of California, Berkeley for undergraduate, and she did PhD in University of California, Irvine, in the same lab where I was. So she worked in something called reinforcement learning, like AlphaZero example I showed, where the machine learns by playing, basically like it's like reinforcing the win or lose errors. So then after graduation, she went on to work in like a research lab, and now she works in a game company where she develops a game. I think AI models for game agents. I'm not sure. She will probably can talk more, but she's a really interesting person and very knowledgeable, and I think we all can learn a great deal from her regarding the current state of AI when it comes to like physical robots or the bots in the games, or like things like that, or these chess players, Go players. So yeah, so I think that will be nice that lecture would be something I really look forward to. So I think you will all enjoy and learn a lot as well.
Thank you. I think এই বছৰৰ কাৰণে আজি আমাৰ 15 মিনিট শিক্ষাৰ last lecture, because next lecture to din to 25th of December or 25th December to Christmas or কাৰণে নহব। So গতিকে সকলোকে নতুন বছৰৰ শুভেচ্ছা আজি জনাইছো আমাৰ তৰফৰ পৰা, আমাৰ সকলোৰে ফালৰ পৰা 15 মিনিট শিক্ষাৰ হৈ। আৰু যোৱা বছৰত আমাক সহায় সহযোগিতা কৰাৰ কাৰণে যিসকলে আমাক আমাৰ লগত সহযোগিতা কৰিছে সকলোকে বহুত ধন্যবাদ জ্ঞাপন কৰিছো। আৰু আজিৰ অনুষ্ঠানটোত আমাক সহযোগ দিয়াৰ কাৰণে SB Deora কলেজ আৰু জাগিৰোড কলেজৰ দুইজন অধ্যক্ষলৈ আমাৰ তৰফৰ পৰা আন্তৰিক ধন্যবাদ জ্ঞাপন কৰিছো। আৰু আমি আশা কৰিছো যে আপোনালোকৰ পৰা ভৱিষ্যতলৈও আমি সহযোগিতা পাই থাকিম। আৰু আমাৰ নেক্সট লেকচাৰটো গতিকে নতুন বছৰতেই হ'ব, জানুৱাৰী 8 তাৰিখে। হয়তো আশা কৰিছো আমি আপোনালোকৰ সহযোগিতা পাম। আৰু আপোনালোকৰ ষ্টুডেণ্ট সকলক আপোনালোকে যদি মানে শ্বেয়াৰ কৰিব পাৰে তেতিয়াহ'লে আশা কৰো ছাত্ৰ ছাত্ৰীসকল উপকৃত হ'ব। আৰু সকলোকে অশেষ ধন্যবাদ জনাই আজিৰ অনুষ্ঠানৰ সামৰণি মাৰিছো। আৰু হিৰকলৈ পুনৰ বহুত ধন্যবাদ জ্ঞাপন কৰিছো। ধন্যবাদ।
ধন্যবাদ।
Thank you, Hirak. ভাল লাগিলে। Happy New Year.
Thank you so much. ভাল লাগিলে।